Hello class. This video is going to focus on 2.2, which is solving one-step equations. The goal of this video is I can solve equations by using addition and subtraction, and also I can solve equations by using multiplication and division. You want to open your textbook to page 75 where you will begin to take notes. So solving one-step equations involving addition or subtraction. So in words, the addition property of equality is if a number is added to each side of a true equation, the resulting equivalent equation is also true. So for any real numbers a, b, and c, if a equals b, then a plus c equals b plus c. And then the subtraction property of equality, if a number is subtracted from each side of a true equation, the resulting equivalent equation is also true. So for any real numbers a, b, and c, if a equals b, then a minus c equals b minus c. Okay, this is example 1. On page 76, we are going to use the addition property of equality to solve g minus 25 equals 113. And we are going to use the vertical method in this class, so we will always use the vertical method. And I know that you can look at this problem and probably use some mental math to solve for g, but we don't want to do that because we want to get in the habit of using the actual method for solving so that when we get to more complicated equations, it's easier. So we have g minus 25 equals 113. So the first thing that I am going to do is I'm going to draw a line down the equal sign. And that signifies that whatever I do on one side of the equation, I also have to do on the other side of the equation. So I'm going to draw a line down the equal sign. And then I'm going to put a box around my variable that I want to solve for. So that means don't touch that variable until I absolutely have to. Okay, so in order to get g all by itself on the left side, I need to move that minus 25. In order to move the minus 25, I'm going to do the opposite of subtracting 25. So the opposite of subtracting 25 is adding 25. And whatever I do on one side of my vertical line, I also have to do on the other side of my vertical line. So we add 25 to both sides. Now what happens is negative 25 plus 25, that's 0. So that's going to cancel out. And then I can bring down my g, bring down my equal sign, and then I have 113 plus 25, and that's going to give me 138. So my answer is g equals 138. So we had to use inverse operations in order to get our answer. Now we can also check to make sure our answer is correct. So in order to check, I'm going to take the original equation and I'm going to substitute my value that I got for my variable. So I'm going to substitute 138 in place of g. So this is my check, just to make sure my answer is right. So instead of g, I'm going to put 138 minus 25 equals 113. And then I'm just going to do 138 minus 25, and I get 113, and that's equal to 113. And as long as they're the same number on both sides, then it checks, and our answer is correct. Okay, this is the check for example 1. This is on page 76. We want to solve 2/3 plus w equals 1.5, and then state which property of equality you used. So the property of equality we're going to use is the subtraction property, because we have to do, we have to do the wait. Yeah, we have to do the opposite. So I'm going to start by drawing a vertical line. And then I'm going to put a box around my variable. Okay, so we need to move the 2/3 to the other side of the equation. In order to move 2/3 to the other side of the equation, I'm going to subtract 2/3 from both sides. Okay, so 2/3 minus 2/3 is 0. Bring down my W. And then I'm going to do 1.5 minus 2/3. And you can use a calculator to do that math. So when you use a calculator, you're going to get 5/6. So W equals 5/6. And again, we use the subtraction property of equality. So I'm going to write subtraction property. So that would be A in your book. And then I'm going to check it really quick just to make sure the answer is correct. So I'm going to take 5/6 and substitute it for W. So I've got 2/3 plus 5/6, and that's going to equal 1 1/2. And then we just want to throw 2/3 plus 5/6 into the calculator, and you should get 1 1/2. So that checks, and we're good. Okay, example 2, solve by subtracting. This is on page 76. Use the subtraction property of equality to solve 27 plus k equals 30. So I'm going to start by drawing a line down my equal sign, put a box around my k, and then I have 27 that needs to move to the other side. So in order to move, I'm going to do the opposite of adding 27, which is subtracting 27. And I got to do that on the other side of the equation too. 27 minus 27 is 0, so that cancels out. And then I have k equals, and then 30 minus 27 is 3. Okay, so there's my answer for k. And then we want to just check it to make sure our answer is correct. So I'm going to take 3 and substitute that into the equation for k. So we have 27 plus 3 equals 30. So then we just do 27 plus 3, and we get 30 equals 30. They're the same numbers on both sides, so our answer is correct. Okay, this is the check for example 2. So solve a plus 26 equals 35. So I'm going to start off by drawing a line down my equal sign, and then put a box around my variable. And then I need to move the 26 to the other side. In order to do that, I have to do the opposite of adding. So I'm going to subtract 26. Okay, so when I do 26 minus 26, that's 0. So it's going to cancel out. Bring down my A equals, and then 35 minus 26 is going to give me 9. So A equals 9 is my answer. And then really quick, I'm just going to check it. So to check it, I'm going to substitute 9 in for A. So I have 9 plus 26 equals 35. And then 9 plus 26 is 35. 35 equals 35. So we are good. Okay, this is example 3. We are on page 77, write a one-step equation. So in tennis, the Grand Slam tournaments are the four most prestigious annual events. At one point in his career, Roger Federer had won 3 more Grand Slam single titles than Rafael Nadal. If at that time Roger Federer held the record for the most Grand Slam singles titles won with 17, how many Grand Slam singles titles had Rafael Nadal won? So complete the table to write an equation that represents the number of Grand Slam singles titles Rafael Nadal won. So we have, in words, Roger Federer won 3 more than Rafael Nadal. And then the variable, we're going to let n equal the number of singles Rafael Nadal won. Okay, so then our equation is going to be, let's see, Roger Federer won 17 equals 3 plus n, which is however many Nadal won. Okay, so now we need to solve that equation for n. So I'm going to start by putting a line down my equal sign, putting a box around my n. And then what is next to n is the plus 3. So in order to move that to the other side, I need to subtract 3 from both sides. So then I have 3 minus 3, which is 0. I'm going to bring down my n, bring down my equal sign, and then 17 minus 3 is 14. So Rafael Nadal had won 14 Grand Slam single titles. Okay, you can also use the multiplication property of equality and the division property of equality to solve equations. So for the multiplication property of equality, if an equation is true and each side is multiplied by the same number, then the resulting equation is equivalent. For any real numbers a, b, and c, if a equals b, then ac equals bc. And then the example we have, if x equals 3, then 8x equals 24 if you substitute the 3 for x. And then the division property of equality, if an equation is true and each side is divided by the same non-zero number, the resulting equation is equivalent. In symbols, that is for any real numbers a, b, and c, where c cannot equal 0. If a equals b, then a over c equals b over c. And then the example is if x equals negative 35, then x over 7 equals negative 35 over 7, or negative 5. Okay, example 4, this is on page 78. We are going to solve each of the equations. So in A, we have 3 over 8x equals 9 over 4. So the first thing we are going to do for A is multiply by the reciprocal of the number in front of the x. So if you remember back to middle school, when you take the reciprocal of a fraction, you are basically just flipping that fraction. So if I have the fraction 3 over 4 and I take the reciprocal, that means I switch the numerator and the denominator, so that becomes 4 over 3. Okay, so taking this reciprocal means you just flip your fraction and multiply by that number. So for A, I'm going to put a box around my x, put a line down my equal sign, and then I'm going to multiply by the reciprocal of 3 over 8. And the reason we are doing this is so we can get x by itself on the left side. Okay, so I'm going to do times, and then instead of 3 over 8, I'm going to take the reciprocal and do 8 over 3. And I'm going to do the same thing on the other side of the equation. Okay, so the whole point was 8 over 3 times 3 over 8, that's 1. Those cancel out. And we're left with x. And then on the right side, let's see, I can reduce this a little. So 4 goes into 8 2 times. So 9 times 2 is 18. Oh, wait. 3 goes into 9 as well. So 3 goes into 9 3 times. So then I have 3 times 2, which is 6. So I get x equals 6 for my answer. And again, we can check our answer by substituting our answer into the original equation and seeing if the two sides are equal. Okay, in B, I have 42 equals negative 14y. So I'm going to start by putting a line down my equal sign and then putting a box around my y. And I need to move the negative 14 to the other side. So right now, this is negative 14 times y, so it's multiplication. In order to do the inverse, I need to divide by negative 14. And when we are solving equations, we always show our division as a fraction. So we do the fraction line under the number. Okay, so I'm going to divide both sides by negative 14. So 42 divided by negative 14 is negative 3. And then equals negative 14 divided by negative 14 is 1. And we're left with y. Okay, so y equals negative 3. And again, we can also check this answer by substituting the answer into the original equation. Okay, this is the check for example 4 on page 78. Solve the equation 6y equals 54. So I'm going to start by putting a box around my y, line down my equal sign, and then I need to move the 6 away from the y. So again, this is multiplication, 6 times y, and the inverse of multiplication is division. So I'm going to divide both sides by 6. 6 divided by 6 is 1, and I'm left with y. And then 54 divided by 6 is 9. So I get y equals 9. And again, to check it, you would take 9 and substitute it into the original equation. And I know that 6 times 9 is 54, so we're good. Okay, that is the end of 2.2a. Remember, you need to get a 75% or higher on the quiz for this video in order to move on.